Welcome students, this is Ravi Shankar going to teach you the electrostatics unit 1 in your first volume. So today what we are going to state as our study is, we are going to study about the heading called to be electric field at a point, along the axial line at a point along the equatorial line, not the axial line. In the last class we have studied about the axial line. So today we are going to study about electrical field at a point along the equatorial line of an electric dipole. Let us see how you can able to see this. So we are going to study about an expression for electrical field at a point along the equatorial line of an electric dipole. So in order to study, let us consider an electrical dipole having a charge minus q at point A and the charge plus q at the point B, and the two charges are separated by a small distance called to be 2A. Let the center point or the origin be O. So OA is A and OB is also A. Now let us consider an point on the equatorial line. That is, equatorial line is nothing but the perpendicular bisector. So you draw a line from this perpendicular bisector point to the point O. So let this be the perpendicular bisector. So this point I am representing it as C. Let us consider this distance OC as R. Now when I am considering this point C, this point is having an electrical field due to what? Having an electrical field due to this positive charge plus Q. So I am joining this plus Q with this point C. Okay, instead of this I am taking this position, taking it as C. So this distance I can say that is BC. I can say that square root of R square plus A square with the help of Pythagoras theorem. So due to this positive charge, the point C is experiencing an electrical field, and the electrical field due to that point charge is acting away because the charge is positive, and let us consider that electrical field as E plus vector. Similarly, if I am considering the point C and the point minus Q, where you can able to get what? Where you can able to get the charge minus Q. So from the charge minus Q, you join what? You join the point C. Due to this negative charge also, you are having an electrical field at this point C. Since this is negative, electrical field is acting towards the negative charge, and let us consider that electrical field as E minus vector. This distance AC is again root of R square plus A square according to the Pythagoras theorem. Are you clear? See, again you are having an electrical dipole having minus Q at A and plus Q at B separated by a small distance to A. Let O be the center point. From the center point you draw an perpendicular line or a perpendicular bisector, that is the equatorial line. On that equatorial line, consider your point C. Let the point C be at a distance R from O. Now the point C is experiencing two electrical fields, one due to this positive charge plus Q and another one due to the negative charge minus Q. So due to plus Q, you are able to get the electrical field as E plus vector, which is acting away from that of the positive charge. that is along BZ. Similarly, if you are calculating the electrical field due to minus Q, then the electrical field is E minus vector acting towards what? Acting towards the negative charge. First of all, let us calculate this E plus value and E minus value. So, first we are going to write electrical field at the point C due to the negative charge, first of all due to positive charge, due to plus Q kept at the point B is equal to, let us consider that as E plus vector. So what is the value? E plus vector is equal to, 1 divided by 4 pi epsilon 0 into Q divided by square of this distance BC. BC is root of R square plus A square. Now you are having whole square along what? The direction what? It is acting along BZ, acting away from that of the charge. Simplify this. I can write like this. E plus vector is equal to 1 divided by 4 pi epsilon 0 Q divided by, taking the square root because it is a square, you will be able to get R square plus A square, and it is acting along what direction? Acting along BZ. Let us take this as equation number 1. Similarly, let us calculate the electrical field at the point C due to negative charge. So similarly, if I am considering electrical field at C due to minus Q kept at A, which is equal to E minus vector. What is this value? E minus vector is equal to, what is the answer? 1 divided by 4 pi epsilon 0 Q by same value, root of R square plus A square the whole square, and it is acting along, look at the diagram, it is towards the negative charge. So it is coming from C to A. So along CA. This is considered to be, let us simplify and take that equation as number 2. You see, when you are simplifying this, you can consider, when you are simplifying, you can simplify. How you can simplify? E minus vector is equal to 1 divided by 4 pi epsilon 0 into Q divided by, on squaring this, R square plus A square, and it is acting along CA. Take this as equation number 2. So comparing equation 1 and 2, you can say, comparing equation 1 and 2, you can state, how you can state, modulus of E plus vector is equal to modulus of E minus vector. That is, the magnitudes are considered to be same because the point C is equidistant from plus Q and minus Q. Why this is? Since the point C is equidistant from the charges plus Q and minus Q. That is the reason why both are considered to be equal. But what happens to the direction? The direction is different. Direction of E plus S along BZ, and direction of E minus S along what? Is along CA, isn't it? From C to A. Now, how you can able to get the resultant? In order to get the resultant, we have to resolve the two values. How we can resolve? See, let us consider the diagram again. When you are considering the diagram again, see, let us do it like this. See, you are having this point C here. Along this direction, you are having E minus vector, and along this direction you are having what? You are having E plus vector. Look at the diagram, you can able to see I have taken the point C alone. See, when you are considering, I have to resolve this E plus vector and the E minus vector into two components. How I can? If I am resolving E plus, one of the value is horizontal component and another one is considered to be what? Another one is considered to be the vertical component. Similarly, when I am taking this E minus, one is horizontal component and another one I can consider it as what? I can consider it as a vertical component. One is the vertical component, another one is the horizontal component. If that is the case, how I can resolve? So in order to resolve that, I am taking the original diagram. What is the original diagram? You see the original diagram? Here you see the point B, the line that is joining from B to C, and the line that is joining from A to C are inclined at an angle. Let us consider that angle as what? Let us consider that angle as theta. If so, at this point, if you are dropping the horizontal line, then we can write this horizontal line inclined at an angle theta to E plus and also to E minus. So, taking this to the second diagram, let us see here the angle is considered to be, this angle is considered to be theta, and similarly this angle is also considered to be theta. Clear? See, again you see you are having the point C, and the point C is having the horizontal line to be drawn like this, which is the reference parallel to that of the axis along this. Okay, now you see you are having this electrical field E1 and E2, E1 and E plus and E minus. E minus is acting along this direction, E minus, and we can state E plus is acting along this direction. Okay, if you are writing E plus in this direction and E minus in this direction, how to resolve these two values, E plus and E minus? So in order to resolve, let us consider a vertical component for E plus and horizontal component for E plus. Similarly, the vertical component for E minus is in the downward direction and the horizontal component along this. So this is the horizontal component of E minus and this is the horizontal component of E plus. The vertical component of E plus is this one and the vertical component of E minus is this one. And this angle is considered to be theta and this angle is also taken to be theta. If E plus is resolved, see E plus, the horizontal component is adjacent. So it is E1 cos theta. The vertical component is opposite to this angle. So vertical component is E1 sin theta. Not E1, it is E plus. Here also it is E plus. Similarly, when I am taking E minus, see E minus horizontal component is adjacent. So I can write E minus cos theta, and the vertical component I can state as E minus sin theta because the vertical component are opposite. Now from this diagram you can say, from the above diagram, it is clear that the vertical components, that is E plus sine theta and E minus sine theta are equal and opposite, since they are equal and opposite, equal and opposite, they cancel each other. Since they cancel each other, we can't able to get the resultant by the vertical component, because the vertical component are cancelling each other. So the resultant component or the resultant electrical field is not due to vertical component, but both horizontal components. You see, what are the horizontal components? Both horizontal components, that is E plus cos theta and E minus cos theta are acting along the same direction, acting in the same direction. Since they are acting in same direction, so they added up. Since they are in same direction, according to superposition principle, it is the vector addition. So they added up to give the net electrical field or to give total electrical field. So total electrical field at the point C can be got by adding the two horizontal components, one as E plus cos theta and another one as E minus cos theta. One is E plus cos theta, another one is E minus cos theta. Both are acting along the same line. So they are added up. Along the same line means they are acting along the negative x-axis. So how I can able to get the resultant then? In order to get the resultant, I am applying the superposition principle. So I can get the net electrical field. I can write like this: E total vector is equal to, what is the value? E plus cos theta plus E minus cos theta, and both are acting along what direction? Negative x-axis. Or I can write like this: along negative x-axis. See, when I am writing this, these are considered to be the magnitude of E plus vector cos theta. This is also magnitude of E minus cos theta along the negative x-axis. So how I can write again? E total vector is equal to, I can write, see, E plus magnitude of E plus cos theta plus magnitude of E minus vector cos theta along the negative x-axis. That can be written as negative, so minus x-axis, it can be written as I cap. Now on simplifying this, I can write like this: it is equal to, what is this? Modulus of E plus cos theta plus, again you can write E minus cos theta modulus and I cap, taking this negative sign in the front side. So putting a minus sign here. Already we have studied that. See, we know that by comparing equation 1 and 2, modulus of E plus vector is equal to modulus of E minus vector. Therefore, how I can write this above equation? See, if you want, you can name this equation as number 3. Let us name this equation as number 3 and let us write. Therefore, equation 3 can be written as, equation 3 can be written as, how you can write? See, E total vector is equal to minus of E plus and E minus are having the same magnitude. So I can write it out as 2 either E1 or E plus magnitude of that vector into cos theta. On substituting minus of 2 into what is this magnitude of E plus 1 divided by 4 pi epsilon 0 either equation 1 or equation 2 q divided by r square plus a square into what is the direction? The direction is I cap. So it is along the positive x side. I cap is minus I cap, it is negative x axis. Negative x axis means I can say instead of I can substitute the dipole moment. So I can write E total vector is equal to I can write like this, isn't it? 2 into Q divided by 4 pi epsilon 0 into 1 divided by r square plus a square into, taking this minus with I, instead of that I can write minus of p cap, because I is from positive to negative, that is minus I, but the direction of the dipole moment is from negative to positive, so it is minus p. Simply we can write again like this, minus of, see, 2q divided by, here I have left out the cos theta, so I am writing here cos theta, 2q divided by 4 pi epsilon 0 multiplied it with r square plus a square into cos theta into p cap. Okay, how to replace this value cos theta? Again we have to consider the diagram. When you are considering the original diagram, I can get the value of cos theta as, see, when I am considering the diagram, you are getting the like this, isn't it? This is the vertical line that you are having. See, this is the vertical line you are having, and here you are having what? Here you are having the dipole having minus q here and plus q here, and when I am joining these two, isn't it, from this point to this point, when I am joining this angle, we are representing it as theta. This value root of r square plus a square, and this one it is r, this one it is a. From this you calculate cos theta. Cos theta is adjacent by hypotenuse, so adjacent is a divided by hypotenuse is root of r square plus a square, which can be written as a divided by r square plus a square whole to the power of 1 divided by 2. Take this and substitute in this equation. So substituting for, okay, substituting for E total vector equal to, or substituting for cos theta, we can write E total vector is equal to minus of 2q divided by 4 pi epsilon 0 into, instead of cos theta it is a by, denominator already you are having r square plus a square, now you are having r square plus a square to the power of 1 by 2 with p cap. So simplify how what you can able to get E total vector is equal to minus of 2q a divided by 4 pi epsilon 0 into r square plus a square whole to the power of r square plus a square whole to the power of 3 by 2, because here you are having the power as 1 here you are having 1 by 2, bases are same, powers can be added, and this can be written as P cap. Now, what is the value of 2qa? 2qa is nothing but dipole moment. See, but 2qa, we can consider like this, but 2qa is equal to P, or we can say P as dipole moment, magnitude of dipole moment. So dipole moment along with the unit vector, it will become vector quantity. So I can write E total vector is equal to minus of P with the unit vector, it becomes P vector whole divided by 4 pi epsilon 0 into R cube. When you are, sorry, not R cube, when you are considering this value, you can state like this, isn't it? 1 by 4 pi epsilon 0. See, when I am writing inside the bracket, R square plus A square whole to the power of 3 by 2. But here I can able to write a special case. If the distance R, that is the distance between O to C, is very greater than that of A, then A square can be neglected. A square can be neglected. Comparing with what? Comparing with R square. So when you are removing or leaving out this A square, we can write the value of E total as out. So we can write the value of E total as E total vector is equal to minus P divided by 4 pi epsilon 0 R square whole to the power of 3 by 2. Here it is P vector. On simplification, minus of P vector divided by, what is the value? 4 pi epsilon 0 R cube. So therefore the final expression is E total is equal to minus of P vector divided by 4 pi epsilon 0 R cube. See, this value, this gives you the magnitude. So therefore the direction of electrical field is, direction of electrical field is opposite to the direction of, opposite to the direction of dipole moment, because the dipole moment is given in terms of what? Dipole moment is given in terms of P. Here you are having minus P. Since you are having minus P, we can say the direction of the electrical field is opposite to the direction of dipole moment.